So in this problem, we have m number of arithmetic progressions. Each of the arithmetic progressions have the first term given by 1, 2, 3. The mth term will be having the value m. And also the common differences are provided. The common difference of the first AP is going to be 1. The second arithmetic progression is going to have a common difference of 3 and so on. And mth term of the AP is going to have a common difference of 2m minus 1. It's also given here that the sum up to the n terms of each of the arithmetic progression are S1, S2, S3. Sum of the mth arithmetic progression up to the n terms, that's Sm. So using this information, we need to obtain the sum, the sum of each of the sums. So let's begin. First, we will specify the first term. So our first term is provided for each of the arithmetic progression. Then we are also provided with the corresponding common difference, including the sum. We will specify the sum up to n terms of the given arithmetic progression. Sum up to n terms. Now, for the first arithmetic progression, though our first term it's given 1. So this is the value. Its common difference is also 1, and the sum up to n terms, that's denoted by S1. Now we're going to use the standard formula. The nth term of n, sum up to the nth term of an arithmetic progression is given by n over 2 multiplied to 2 times a plus n minus 1 times the common difference d. So here e represents the first term. Now the sum of S1, this will be the sum up to n terms of the first arithmetic progression. So this is going to be n over 2 multiplied to 2 times the first term, which is 2 times 1, plus n minus 1 times the common difference d, which is also 1. Solving this, we are going to get n over 2 multiplied to n plus 1. Fine. Then we move on to the next arithmetic progression. So this is first AP number 1. Then we move on to the second arithmetic progression. So here the first term of this second arithmetic progression, that's 2. The common difference is 3. So that means the sum to n terms of the second arithmetic progression, the sum is denoted by S2. So this will be equals to, since we are calculating the sum up to n terms, we're still going to have n over 2 multiplied to 2 times the first term. So our first term is a, 2 times 2 is going to be 4. So we have 4 plus n minus 1 times the common difference, that's 3. This is going to give us n over 2 multiplied to n plus 1. Let's move on to the third arithmetic progression. So for the third arithmetic progression, the first term is given by 3. The common difference is 5. So the sum up to the n terms was denoted by S3. So this is going to be equals to n over 2 multiplied to 2 times the first term. So 2 times 3 is 6 plus n minus 1 times the common difference. So that's 5. So here I have missed a 3. So this is going to be 3n plus 1. This is going to be equals to n over 2 multiplied to 5n plus 1. So that means we can see the trend here. So we can continue up to the mth arithmetic progression. So this is the mth arithmetic progression. So its first term is m, and its common difference, that's given as 2 times m minus 1. And the sum up to the n terms is denoted by Sm. So this is going to be equals to n over 2 multiplied to 2 times the first term plus n minus 1 multiplied to 2m minus 1. So this is the common difference. So let's further simplify this. This is going to give us n over 2 multiplied to, so we have 2m plus 2 times m times n minus n minus 2m plus 1. So positive 2m, negative 2m goes away, and this is going to give us n over 2 multiplied to 2 times mn minus n plus 1. Now we have all the sums up to the mth arithmetic progression. So we're going to find out the total sum. So our sum S1, this is the sum up to n terms of the first arithmetic progression. Then we have S2, which is the sum up to the n terms of the second arithmetic progression, plus S3 similarly added to all the way up to the mth arithmetic progression. So this is going to be equals to, for the first one we obtained n over 2 multiplied to n plus 1. For the second sum we had n over 2 multiplied to 3n plus 1. For the third one we had n over 2 multiplied to 5n plus 1. This one goes all the way up to the last sum, which is n over 2 multiplied to 2mn minus n plus 1. Fine. Now we can take n over 2 as the common factor from all the sums. So we have n over 2 whole multiplied to n plus 1 plus 3n plus 1 plus 5n plus 1 plus all the way up to. So here if we take n as the common factor, so we have 2m minus 1 multiplied to n plus 1. Now we have n over 2. So we'll combine all the n terms together. So we have n plus 3n plus 5n all the way up to 2m minus 1 times n. And then we have all the ones. So we have 1 plus 1 plus 1. This goes all the way up to the last one. So here we have a total of m number of terms. Similarly, for the one added to itself, so this is also going to have m number of terms. Fine. So let's find out the sum of each. Now we'll be applying the formula for the sum. So here we note that the sum formula is given by s of n equals to n over 2, where n represents the sum up to the n terms. So the n is the number of terms here. We have the first term plus the last term. So here we will have n over 2 multiplied to, so since it's got m number of terms, so we have m over 2 multiplied to the first term, which is n, plus the last term, which is 2m minus 1 times n. That means we have 2 times mn minus n, plus we have 1 plus 1, which is added to itself m number of times. So this will be simply 1 multiplied to m. That means we now have n over 2 multiplied to m over 2 times. So here negative n, positive n goes away. We have 2 times mn plus m. Right. So here the 2 and 2 goes away. That means we now have n over 2 multiplied to m times mn will be mn squared plus m. We can pull out the m from the two terms. So we have mn over 2 multiplied to mn plus 1. So this is going to be the sum s1 plus s2 plus s3 all the way up to the sum up to the n terms of the m at AP.